Welcome students. This is the third part of the methods to enhance the dissolution rate and bioavailability of poorly water soluble drugs. So the next method to increase the dissolution rate is by forming a eutectic mixture. eutectic mixture बना के हम उस सब्सटेंस का डिसोल्यूशन रेट एंड बायो अवेलेबिलिटी बढ़ा सकते हैं. So these systems are also prepared by a fusion method. So like that of solid solution method, here we also can prepare a substances which is having a melting point than their individual melting point. So eutectic substances melt the different from the solid solutions in that the fused melts of a solute solvent shows the complete miscibility but at a negligible in case of solid solubility. Such systems are basically intimately blended a physical mixture of two crystalline components. So by this phase diagram we can understand how the eutectic mixtures are prepared. So take an example. This is a substance which is called as solid A substances and this is a B substances. They are mixed together but they melt at this temperature point. So that is a eutectic point than their individual melting point. So the melting point of pure A component is here and the melting point of pure B component is here. But rather than going to their individual melting point, these two substances liquefy at a common melting point. So these are called as eutectic mixtures. So after the formation of substances, the substances are formed in a crystalline form. So the crystalline form of these substances are having a enhanced dissolution rate and solubility. Example, the paracetamol and urea. This is the best example of eutectic mixture or eutectic substance or a drug. Next, this method is having some of the limitations. The first limitation is drugs which fails to crystallize from the mixed melt. Means there is a mandatory to crystallize the substance after a fusion. जैसे ही फ्यूजन होता है दोनों सब्सटेंस का तो उसका मेल्ट होने के बाद क्रिस्टलाइजेशन होना यानी क्रिस्टल फॉर्म में कन्वर्ट होना बहुत ही ज़रूरी है. इफ़ वन सब्सटेंस इज फेल्ड टू फॉर्म in a crystalline form, then it is not suitable by this method. Next, drug which are thermolabile means those substances which are heat sensitive cannot be converted into a eutectic mixtures. Means substance must be a thermolabile, thermostatically stable. So our next method is solid dispersion methods. So these are generally prepared by a solvent or a co-precipitation method. या तो एक solvent या co-precipitation method से भी बना सकते हैं. Whereby both the guest solute means a drug solid substances and the solid carrier solvent are dissolved in a common volatile liquid solvent such as alcohol. तो ये मेथड में क्या किया जाता है? First of all, a guest solute or a solid substances. Simply we can say that a drug substances and a solid carrier solvent, जो भी एक solvent है, इन दोनों को क्या किया जाता है? एक ऐसे ऑर्गेनिक सॉल्वेंट में डिजोल्व किया जाता है जो कि दोनों को भी डिजोल्व करने की एबिलिटी रखता है. मीन्स डिजोल्व इन ए कॉमन वोलाटाइल लिक्विड सॉल्वेंट सच एज अल्कोहल. The liquid solvent is then removed by evaporation under the reduced pressure as we studied in the pharmaceutical engineering. So ये evaporation method से उसमें का जो भी कुछ organic solvent है उसको हम क्या करते हैं? रिमूव करते हैं. और by a freeze drying technique which results in the amorphous precipitation of a guest solute substances in a crystalline carrier. क्रिस्टलाइन कैरियर में क्या होता है? ये अमॉर्फस फॉर्म में प्रेसिपिटेट हो जाता है. Thus, in case of solid dispersion, the drug is prepared आउट इन एन अमॉर्फस फॉर्म, ड्रग जो होता है वो अमॉर्फस फॉर्म में क्या होता है, बन जाता है. While in case of solid solution method, the drug is precipitated out in the form of crystalline. Okay, so by this graph we can say that as the time passes, time in minute, and the concentration of griseofulvin, they have given an example of solid dispersion, that is griseofulvin with a polymer, that is polyvinyl pyrrolidine, that is PVP. As we can see, whenever there is a decreasing order of ratio of griseofulvin to PVP, 1:20 shows the enhanced dissolution rate. Next, 1:10 decrease, again griseofulvin and PVP 1:5. So this graph shows decrease in the dissolution rate. Finally, as usual, our traditional method, that is a micronized griseofulvin, that is a griseofulvin by size reduction method, shows a very less dissolution rate compared to all these solid dispersion technique. So this graph shows the dissolution rate enhancement of griseofulvin by solid dispersion technique. So our next method is that molecular encapsulation with cyclodextrin. So this is the last method of dissolution enhancement. So before going to the molecular encapsulation with cyclodextrin, one should know what is cyclodextrins. So a cyclodextrins actually में है क्या? So these cyclodextrins are nothing but these are the oligosaccharides. ये क्या है? Oligosaccharides है. ये कहाँ से बनाते हैं? स्टार्च. दे आर प्रिपेयर्ड बाय एंजाइमेटिक एक्शन ऑफ स्टार्च. कुछ माइक्रो ऑर्गेनिज्म के स्ट्रेन्स को यूटिलाइज करके स्टार्च में एंजाइमेटिक एक्शन को बना के ये साइक्लोडेक्स्ट्रिन्स बनाते हैं. द बीटा एंड गामा साइक्लोडेक्स्ट्रिन्स एंड सेवरल ऑफ देयर डेरिवेटिव्स ऑफ साइक्लोडेक्स्ट्रिन्स आर यूनिक इन हैविंग द एबिलिटी टू फॉर्म ए मॉलिकुलर इंक्लूजिंग कॉम्प्लेक्स. तो ये जो बीटा एंड गामा स्ट्रेन्स है साइक्लोडेक्स्ट्रिन्स के, तो इनमें क्या होता है, एक यूनिक कैपेसिटी होती है, एक यूनिक एबिलिटी होती है. वो क्या कर सकते हैं, मॉलिकुलर इंक्लूजन कॉम्प्लेक्स फॉर्म करते हैं किसी भी ड्रग सब्सटेंस के साथ विद द हाइड्रोफोबिक ड्रग्स, स्पेशली विद द हाइड्रोफोबिक ड्रग्स, बिकॉज वी वांट टू इंक्रीज द सोलबिलिटी ऑफ दीज टाइप्स ऑफ ड्रग्स which is having a poor aqueous solubility. So these buckets means cyclodextrin bucket shaped oligosaccharides produced from starch are versatile in having a hydrophobic cavity of a size suitable to enough to accommodate the lipophilic drugs as a guest. तो इसमें क्या होता है, एक ऐसी शेप एंड ऐसी एबिलिटी होती है और ऐसी जगह होती है कि किसी भी लिपोफिलिक और हाइड्रोफोबिक ड्रग को खुद में समा सकती है. The outside of the host molecule is relatively hydrophilic. Thus, the molecularly encapsulated drug has a greater improved aqueous solubility and dissolution rate. So, here we can see by the figure or diagram. So, this is the molecular inclusive complex of aspirin drug by this cyclodextrin. So, we can see here clearly this is the outer surface of the cyclodextrin which is relatively a hydrophilic exterior part, that is a water soluble. So inside that a hydrophobic cavity is there which is having an ability to include the hydrophobic drugs or lipophilic drugs, the cavity for encapsulating the hydrophobic drugs. So here they have shown the entrapped aspirin molecules inside. So here we can see the aspirin molecules. So in this way the hydrophobic drugs, though they are relatively less soluble, but the dissolution rate and the solubility can be enhanced by these types of techniques. So that's why the cyclodextrins are extensively utilized due to their exterior hydrophilic characteristics. So this is the end of the methods to enhance the dissolution rate and bioavailability of poor soluble drugs. Thank you.